Okay, so today we're going to continue looking at systems that have three variables. Remembering that anytime we have three variables in a system of equations, that system must contain three equations as a minimum. So when we have this situation, we're going to start off by picking one variable that we're going to eliminate from the problem. Just whatever variable you choose, it really doesn't matter. Once we do that, we're going to eliminate that variable twice from two different sets of equations, two different pairs of equations. Once we do that, we'll have two new equations that will be a new system that only has two variables in it. So we'll have two equations with two variables at that point, and at that we'll use the substitution or elimination methods to solve that system of two equations. And then we'll take the answers and substitute back into the beginning to find all of the values for the three variables that we started off with. So what we're going to do now is we're going to jump in and look at a few examples. I've placed the steps that we're going to follow over here on the side of the screen, just kind of as a little checklist as we go through this. We've got a worksheet, or you should have a worksheet in your hand that will go along with this video. And we're going to start off by taking a look at number 2 on this video sheet. Now, as you look at this, and I can see I've got a typo here, that should be a Z. But as we look at this, we can choose to eliminate X, Y, or Z. Most of the time we're going to, pick out something that we feel like we could probably eliminate with the least amount of complication. In this case, it doesn't really look like one is going to be particularly easier than any of the others. They're all fairly simple to work with. Let's just say we're going to eliminate the variable Y, or let's eliminate the variable X. And I'm just going to write up here as an abbreviation, we're going to eliminate X. And that's going to be our strategy as we go through the first two equations, or the first pair of equations that we're going to work with. So if I pick to work with these first two equations and I'm going to eliminate the X, I'm going to keep this variable, or this one, the same. So I'm just going to multiply it by 1. I'm going to take this second one and I'm going to multiply it by -2. Now in doing so, this is going to give me two new equations. So, well, the first one will actually be the same. So I'll have -4x minus 5y minus z is equal to 18. And working with the second equation, I'm multiplying everything by -2. So I'm going to get positive 4x. I'm going to get positive 10y. I'm going to get positive 4z, and I get -24. So I'll get all those values by multiplying the entire second equation by -2. So at this point, what we'll do next is we will combine our values from the two equations, and you can see that these two are going to cancel. -4x and plus 4x, or positive 4x, will cancel, and the x's will be eliminated, which is our task. -5y and plus 10y will make positive 5y. -z and positive 4z will make positive 3z. And then 18 and -24 will combine to make -6. So we have one equation here, 5y plus 3z equals -6. And we're going to work with that a little bit more in just a moment. But before we do, we're going to create another equation that also does not have x in it. So we'll take the second two equations, or another pair. It doesn't necessarily have to be the second two, but I usually use the second two. So as we go through this, we can see that if we want to eliminate x again, this is the goal, we're going to need to get, these are very similar to each other, but we're just going to need to get one of those to be positive. So what I'm going to do is I'm going to multiply this first one by 1. I'm going to multiply the second one by -1, and that'll change all those signs to help us along the way. So as I do this, I guess I need to come down here a little bit more. We're going to have negative 2x minus 5y minus 2z equals 12. And then in our next equation, we'll have positive 2x. Remember, multiplying -1 just basically changes all the signs. Negative 5y, negative 2z, and it'll be equal to -4. Now, you might look and see that everything's going to cancel out, but only one thing cancels, and the others basically just get larger. So as we look, the negative 2x and the positive 2x will cancel. Negative 5y and negative 5y actually make negative 10y, and negative 2z and negative 2z make negative 4z. So we get negative 10y minus 4z. 12 plus -4 makes 8. So we get our second equation now. So what we've done is we've picked a variable and we eliminated it. That was the x. We eliminated that x twice to make two new equations. Here's equation 1, here's equation 2. We're going to use these in just a moment. We're going to solve the new system of two equations with two variables. And then we'll work backwards from there. So I am going to move my screen down just a little bit. And I'm going to take these two equations that we have, 5y plus 3z equals -6, and negative 10y minus 4z equals 8. And we will solve this system now using the techniques we've already looked at. Hopefully, as you see this one, it's kind of screaming out to me, and hopefully it is to you as well, that we need to probably go ahead and eliminate y's in this problem. So I'm going to take this first equation and I'm going to multiply it by 2, and I'm going to multiply this one by 1. That's going to keep this as negative 10 on the bottom, and it's going to make this 5y turn to positive 10y. So when we have that situation, the y's are going to obviously cancel out real quickly for us. So we have multiplied by 2, we get 10y plus 3z. No, that's incorrect. I'm sorry. Let me erase that real quickly. We will get positive 10y. 3z times 2 will be 6z equals negative 12. That's multiplying everything in the problem by 2. Multiplying the other one by 1 will be negative 10y minus 4z equals 8. We go to combine all of these, and we find that we get 2z, as these two canceled out. 2z is equal to negative 4. Well, hopefully that's telling you that z is equal to negative 2. So that is the first part of our answer. What we do with it at that point is we're going to take that and go plug it in to one of the other equations that we just had. I'm choosing this second one, negative 10y minus 4z equals 8, and we plug that in. So I've got, as I do that, I've got, and I'm just going to come over here and do a little scratch work, 10y minus 4 times negative 2 equals 8. Well, 4 times negative 2, of course, is minus 8, so I've got 10y minus negative 8, so that's going to turn to plus 8, equals 8. Well, you subtract 8, you get 10y equals 0, so we find that y is 0. So I've got two of my variables. Just once I found this first one here, the z, I just go backwards with it, find out what y is, very similarly by plugging it into another equation, and I'm going to take the z and the y that I've just found, and I'm going to go back to one of these other equations. Say I take it to this one right here. So I'm going to be able to find x. I've got negative 2x, and I'm going to try and cram it in this little space, plus 5 times, we said y was 0, so that's a quick one. Plus 2 times, we said z was negative 2. And I apologize for running over some of these other lines, but and that's going to equal 4. So as we work all this out, that's going to be negative 2x plus 0, and this would be minus 4, is equal to 4. When we add over, we get negative 2x. These make negative 4, and we add that, so we get negative 2x equals 8, so x must be equal to negative 4. So our final solution is negative 4 for x, 0 for y, and negative 2 for z. This is the answer to this system of equations. Okay, we're going to continue by looking at number 7 on the sheet. As you look at number 7, it does look a little different. And I've actually insinuated the difference here in this second equation by pointing out that there is a space here, meaning that there is a z missing from that second equation. Now, as we do that, or work with that idea, that simply just tells us that we can take two of the other equations and eliminate z and save this one as one of our two equations. So I don't have to eliminate z from that. I've already got it eliminated. So what I'm going to do is take the first one and the last one and eliminate z from there. So I'll keep this top one the same by multiplying it by negative 1, or excuse me, positive 1, and I'll multiply this one by negative 2. And that should give me a positive 2z here to cancel out with this negative 2z. So let's take a look at what happens when we do this. We've got x minus y minus 2z equals negative 6. We go to this bottom one and multiply everything by negative 2, so that would be positive 8x. Positive y times negative 2 would be negative 2y. Negative z times negative 2 would be positive 2z. And negative 2 times 12 would make negative 24. So we go to combine all of these, and we get a second equation. That's going to be 9x. The y's make negative 3y, or minus 3y. Z's will, of course, cancel out. And we get negative 30 right here. So what I have is a second equation that I can use with this equation for my second system of equations to work with. So I picked one variable to eliminate. I decided I was going to eliminate z since I didn't have one already in the second equation. I eliminated it. I didn't have to eliminate it twice, but I made two new equations. I've got this one with only two variables, and I've got this one, 9x minus 3y, with only the same variables as well. And then I'm going to solve now this system of two equations with two variables. So I've got 3x plus 2y equals negative 25. I've got 9x minus 3y equals negative 30. And of course, I'm going to just use this. I can eliminate x or y. If I choose to eliminate x, which is what I would probably do here, I would multiply this equation by negative 3. I'm going to keep this one the same. And that will give me a negative 9x on this first one. And that's going to make minus 6y equals 75. Positive 75, because negative 25 times negative 3. Over on the next equation, I'm keeping it the same. So I've got 9x minus 3y equals negative 30. Now as we go to combine, you'll see that some nice things happen. The x's cancel. Negative 6y and negative 3y make negative 9y. and that would be equal to 75 minus 30, which is 45. And this tells me that y is equal to negative 5. Well, if y is equal to negative 5, we're simply just going to take that and plug it into this equation here. And that would give me, just come down below, 9 times x minus 3 times negative 5 is equal to negative 30. Negative 3 and negative 5 make plus 15, so that's 9x plus 15 equals negative 30. Well, if you subtract 15 from both sides, you're going to be left with 9x equals negative 45. And again, that tells me that x is also equal to negative 5. So I get x is equal to negative 5, y is also equal to negative 5, and then we're going to want to go to one of the other equations. I definitely want to find z, so I'm going to go to an equation that contains z. So I'll go back to this first one right here, or the third one actually in the original problem, negative 4x plus y minus z. As I start plugging things in, that's going to be negative 4 times negative 5 plus y, so that would be plus negative 5. I'm just going to put minus 5 for the y, and then minus z equals 12. So this is going to be 20 minus 5, so that makes 15 minus z equals 12. And from that, you should be able to find that z is equal to 3. So our final solution there, and again, forgive me for cramming it all in one area on the screen, but our final solution is going to be negative 5 for x, negative 5 for y, and 3 for z. So we get negative 5, 3. Okay, in our third example for the video, we're going to look at number 9. Number 9 is a very interesting looking problem. If you take a moment and glance at it, we first off recognize that we're missing a z here. So that's probably telling us that we want to eliminate z from one of the other pairs. But as we go to look at the other two equations, you can see that this one is just a little funny looking. It doesn't quite look the way it should look, basically because it's got the z all by itself and the x and the y are on the other side of the equation. If you're going to do elimination, I always strongly suggest that you would get all of your variables on one side and pretty much in the same order as you have them in the other problems or the other equations in the problem. This way you can line things up a lot easier and see what needs to actually be done to complete the elimination. So what I'm going to do is I'm going to rewrite this equation. I need to get the x and the y over on the other side. So if we have z is equal to negative 3x minus 3y plus 9, and I want to get these two values on the other side, I'm going to just simply add 3x and add 3y to the other side of the equation. Okay, now in doing that, that's going to give me 3x plus 3y plus the z that was already there is equal to 9 would be what's left on that side. This is the equation I want to work with. It's the same version of this, but it's a nicer version if I'm going to try to do elimination in the other part of the problem. So we're going to clean that up, and I'm actually going to type that in and put it down below here. Give me just a moment here. Okay, so I've added that in, and I'm going to try and move some of this other stuff just kind of out of the way here. And you know how that always can be. Let me just use the eraser here real quickly and clear some of this out of the way so we can work with it. But I just want you to see how I've actually done this. I've rearranged the second equation so that it became rewritten as this that I have on the bottom. This is the same thing that I have here. I've just rearranged it so that I have everything kind of lined up. As I look at this, and remember that my goal is to eliminate z, I can see that I'm really not going to have too hard of a time doing that. I'm just going to take this first one and keep it the same. I'm going to take the second one and I am going to multiply by -1. And in doing so, I get negative 4x plus 5y plus z is equal to 8. On the bottom, I'm going to get negative 3x minus 3y minus z is equal to negative 9. Now, that works together pretty good. And I get negative 7x, 5y and minus 3y make positive 2y. The z's obviously are going to cancel out, and 8 and minus 9 or negative 9 make negative 1. So I have negative 7x plus 2y equals negative 1, and I have 3x minus 3y equals negative 6. Remember, my goal is to get a new system of two equations with two variables. If I can get that, I'm going to be okay. I can solve for the two variables using substitution or elimination. So we go write these out, and I'm just going to kind of come over here and write them out. 3x minus 3y equals negative 6, and negative 7x plus 2y equals negative 1. Now this one isn't quite as neat as we would like to have. Let me just clear that out. I'm going to probably choose to eliminate y in this case. It just seems to be a little bit easier. The 3 and the 2 are obviously probably going to be a little easier to work with than 3 and 7. You don't have to do it that way. It's just what I'm choosing to do in this particular problem. So to do that, I'm going to multiply my top equation by 2. I'm going to multiply my bottom one by 3. And that is going to give me some y values that it will cancel out. And multiplying by 2, I get 6x minus 6y equals negative 12. And multiplying this one by 3, I get negative 21x. Multiplied by 3 there gives me plus 6y. And multiplying by 3 on the last term gives me negative 3. So hopefully that little window will go down. 6 and negative 21 will make negative 15x. The y's cancel out, and we get negative 15 over here. So I get negative 15x equals negative 15. So that's telling me that x is equal to 1. Negative 15 divided by negative 15. Again, I don't know why that little window is popping up. There we go. I got rid of it. So I've got x is equal to 1. And really all I need to do now is go backwards and plug some things in. I can go back to this 3x minus 3y equals negative 6, or really anything I want to go back to. But I'll take this, and I'm going to come down here. So I have 3 times 1, 3. We said x is 1 now, so we put 1 in place of it. Minus 3y equals negative 6. That's 3 minus 3y equals negative 6. You subtract 3, so you get negative 3y equals negative 9. And y is then equal to 3. So we know x is 1, we know y is 3. So we can come back up here, choose any of these that we have from the beginning. Remember, I rearranged some things, so we've got some options to work with. I just want to make sure that it has a z in it so I can find what z is. Let's say we use, let's just say we use this one. I don't know that it matters. We've got negative 4 We're going to multiply that times x, which is 1. Then I've got plus 5y, or y, of course, is 3. So that's 5 times 3. And we're going to say plus z is equal to 8. And finishing out, that would be negative 4 plus 15 plus z equals 8. In other words, negative 4 and plus 15 are going to make, what's that, 11 plus z is equal to 8. You subtract over and you will find that z, and I'm running out of space, z is equal to negative 3. So we can write our answer out now as x is 1, y is 3, and z is negative 3. And this is our final answer for this system of equations that we have in number, I believe this was 9. Yes, in number 9. So the answer to 9 is 1, 3, negative 3. Okay, so that brings us to the conclusion of the video. You have several other examples here to practice on your worksheet. Hopefully you take some time and work through these. Hopefully I've given you enough information and some guidelines to kind of follow as you approach each one. The key here is that no two problems are going to be exactly the same. You're going to have to go through the process multiple times and get used to working with them so that you can develop your strategy as you go. Each problem you're going to take the base strategy that we've talked about here, and you might have to make some modifications as you go to each problem. We looked at a couple of examples here where we decided that we didn't need to go through all of the work, and we just had to eliminate one variable in a certain case because we could see that it had already been eliminated in another one. So you always should be looking for options like that, looking at which variable is going to be the easiest to eliminate and vice versa, and working with these things. So continue to practice, and hopefully you will get to where you need to be. I will see you in class.